Okay. So we have covered chemical bonding, gas, liquid, solid, intermolecular forces, solution. This one already covered in your test 1 to 4 already covered in your test 1. And now we have covered acid and base, chemical equilibrium. Today we go electrochemistry, means we will look at positive, negative terminal, means what charges go to positive side, what negative charge go to positive side. So this one we try to clear at least half of this. Then we continue next Tuesday, replacement class. So by next week or another 2 more weeks, we can finish chapter 8. So basically chapter 5, 6, 7, 8 will in your test 2. Each chapter 1 question. And your final exam will have 8 questions, 1 chapter, 1 question. Okay. So chapter 7, we'll look at redox chemistry. Redox chemistry means you will see positive charge, negative charge, and then they'll go to anode, cathode. It's like a battery. We'll study battery basically. So then we will apply the redox chemistry, equation 1, equation 2 in galvanic cell. Okay. Then in the galvanic cell, we will decide which one is positive charge, which one is negative charge, and so on. Then we apply in the battery and fuel cell. So fuel cell is another chapter if you go into degree level later. So foundation, we just give you information. In your final, I won't ask you fuel cell, right? But I will ask you the 3 dot here, redox chemistry, galvanic cell, and potential. Okay. So basically, some of this you already learned in your SPM chemistry. We just go a little bit more. Okay. So most of the guys here, you know what is Mirai. So Mirai actually is the first fuel cell vehicle. We need to introduce you because it's your generation that you will see fuel cell on the road. Yeah. So fuel cell means without using petrol, you use battery power or EV cars, right? So previously it was known as fuel cell, but nowadays it was rebranded as EV car. All right. So Mirai is the first in the world, right? So yeah, so Mirai a lot of hydrogen. So this one, but this one I won't ask you about this one. It's just a introduction of what is the internal combustion engine, and yeah, maybe not in my time, maybe in your 60s, 50, maybe that time, no more petroleum, then you see the end of internal combustion. Right? Okay, so just an intro. What is hydrogen fuel cell? Hydrogen oxygen fuel cell. Basically, this is not in your test. For info, this is just information, right? So basically, you take hydrogen plus oxygen, combine through a process, it will get water. Okay, I won't ask you in test. This is just an introduction of what is hydrogen fuel cell. Basically, you're combining 2 gas. You take hydrogen, take oxygen, combine, you get water. So how to get water is because of the process. You force the hydrogen become H2 become H plus. Oxygen, you become O2 negative. You force them break away. Then they combine again in another chamber. Okay. Okay, this one you read lah. I won't go through this one. Okay. So what is important later? We will use the word redox. Redox reaction means it's a combination of oxidation and reduction. In chapter 7, we will keep repeating this word. Chapter 7, you will see reduction and oxidation. Okay, in chapter 7 kind of question, you need to identify what is reduction process what is oxidation. So basically, it's the movement of electron. It's a movement of electron. We'll look into detail. Okay, so we start looking at. Okay, now there are a few definitions of reduction and oxidation. We look at the first one, which is the transfer of electron. Transfer of electron. If you have an electron moving around, reaction happen, you will have a redox reaction. Okay. So you see a car corrosion happen, it's a redox reaction. You see battery, the battery that we use nowadays, your handphone battery, all these are redox reaction. It's a movement of electron. Okay. Apple oxidation, right? Those that like apples, if you leave it for a few hours, you will see chocolate color. So this is also redox reaction. Okay, so in test, sometimes we'll ask you, give some daily example, give 3 daily example of redox reaction. So these are the example that you can memorize. Corrosion, corrosion on the steel, application of battery, lithium battery and all this, and then the oxidation happen on the apple. If you left it exposed to air and so on. So these are the 3 examples of redox reduction that happen in daily life. And if the question asks you, give 3 examples of redox reaction in your daily life, these are the 3. You make it into sentence. Okay, we start to see example. Okay, so these are the example of redox reaction. I want you to observe the similarity of what is the redox reaction. First one is hydrogen fuel cell. You take hydrogen, oxygen, become water. Rusting of iron. This is rusting of iron. Ferrum plus oxygen. Because how you get rust is because iron exposed to oxygen, you get rust. So ferrum plus oxygen, you get ferrum oxide. And CH4 and oxygen, you get, this is the, CH4 is a methane, is a flammable liquid, plus oxygen, you get CO2 and water. So you will see this equation in chapter 8. You will see the last equation in chapter 8, where we look at the hydrocarbon later. Okay. So what do they all have in common? So this reaction involves one or more element gaining oxygen. Okay. So first definition, just now you say it's a transfer. So oxidation, you see the word oxidation, first definition, oxidation means origin from oxygen. If oxidate means you plus oxygen. It's the opposite of each other. Reduction and oxygen actually is the opposite meaning. If oxidation means plus oxygen, if reduction means remove oxygen. First definition is oxygen. So, so you can see H2 plus oxygen, ferrum plus oxygen, CH4 plus oxygen. This is oxidation. Or yeah. So this is a redox reaction. Okay. So substance that gain or get oxygen, they are oxidized. We use the word oxidize or oxidation happen. Okay. Okay, so this is just a very direct definition. Or in your short note, you just write plus O2, but in the test, you need to extend this one. Oxidation means you gain oxygen or there is an additional of oxygen. Reduction means you remove or loss of oxygen. Okay. First definition, we look at oxygen. Okay. Okay. Now consider these same three reactions in reverse. Just now we look from the process left to right. What happens if from the right to left? Okay. So if from the left to right or forward reaction, these two plus oxygen means this is oxidation. Yeah. If the process reaction is from the left to right, that get oxygen, you see plus oxygen in the reaction is the oxidation. If you reverse, let's say H2O, reverse means H2O break into H2O2 is a reduction process. Yeah. So we have two directions, forward and reverse direction. Okay. Okay. So first is oxygen. What happens if there are some chemical that do not involve oxygen, for example, battery? All right. So if the process that do not oxygen, this oxygen definition cannot be used. If it do not oxygen, but it still happen corrosion, it still can supply energy, like battery, then we need another definition for oxidation and reduction, which is the movement of electron. Okay. So the word is electron. The second definition is electron. So here, so lithium atoms lose electron to become positive ion. Lithium is oxidized. So how can you move this one into a handwriting or short form of notes for you? Means lithium lose energy, means oxidation means minus electron. Minus electron means throw away electron, it become positive charge, correct? So oxidation means lose energy. Reduction means plus energy. Plus electron, sorry, not. There are two definitions for reduction and oxidation. You can either use oxygen or you can use the transfer of electron. So in this case, from this definition, oxygen and transfer of electron, you should able to use the word oxidize. You need to know which object is oxidized in the process. Means I'll give you a question, blah, 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 blah. At the end, you need to know, you need to tell me which element is oxidized based on the definition that we write on the whiteboard here. And then you prove lah. In the question, you prove by equation, here move there, here and there, then so A oxidized or B oxidized. Okay? Okay. So here you see the word tendency. Tendency means a strong tendency to lose electron means you want to let go electron. Okay. Again, back to the periodic table. I draw something on the whiteboard. Brian, maybe you need to pay attention a bit on the periodic table. Okay. So periodic table, you know that this is group 1, group 2, group 3, group 4, and so on, right? 2, 3, and this is 6, 7, 8. For example. Okay, group 1, 2, 3. Group 1, 2, 1 to 3. And group 6 to 7, 5 to 7. They are the one who play with the electron transfer. Group 1, 2, 3. Group 1, 2, 3, what does it mean? Means column, huh? Group 1, 2, 3, what does it mean? Means that, like for example, group 1 in periodic table means they have one electron outside. If they have one electron outside, if they have less than 4 members in the orbit, they are more easier to kick them out. Remember, group 1 to 3, they are more tendency to let go electron, based on periodic table. It means if you have less than 4 members, 4 members, it depends on situation, but less than 4 means 1 to 3 electron outside, means they're more easier to let go electron. More to let go means they are more easier to have oxidation. We mean the group number 1 to 3, they are more easier to be oxidized. Means some question in final will force you to use periodic table to tell me which one is oxidized, which one is not. Okay, now group 5 to 7 means there are more member already. More member outside the orbit means they are more easier to influence or pull electron to them. Okay, pull electron to them means that group 5 to 7, they are more tendency to receive electron, means they are more tendency to have a reduction process happen in a group 5 to 7 in the periodic table. Now, this one do not tell in the textbook one. It's just that the summarize of the whole textbook, what does the periodic table tell you? By experience. Okay, so this is important, understanding of periodic table. And then later on, when you write the equation, you should know like which one will give electron, which one will receive electron. You need to refer back to periodic table. Yeah, right. Now, for this chapter, you always need to write the half equation. Half equation means what happened to that particular element. For example, lithium. Lithium is group 1. So it will let go 1 electron. So you need to break lithium into ion. If we let go electron, means you like Li plus, because you let go 1 electron, it become 1 charge, 1 positive charge plus 1 negative charge. Okay. So this is just an illustration just to tell you from a periodic table what actually happens. So lithium ion, if it's let go, it become ion plus electron. So the electron will transfer, means electricity can flow. Okay. So electron also will discharge or charge something. Okay. This one you read lah. This one you read. Okay. So okay, gain, electron are gain. So still back to my whiteboard note. Electron are lost, are gained by non-metals, become negative ion, and non-metal is reduced. Means if you get positive, if you plus E, you under a reduction. You are, another word is called reduce, means something reduce in your answer. Means group 5 to 7, they are more easier to be reduced because they are more tendency to receive electron. The rest you read. The rest is to keep repeating what happened to the electron. Yeah. So this is just elaboration of what we have on the whiteboard. Okay. Okay, this diagram is just tell you when some element, if it let go 1 electron, another element will receive it. So from here, if the red color let go electron, which is negative E, let go, means it is oxidized. And the blue color, it accept, it is reduced. Means oxidation and reduction. So red color is having oxidation, blue color we're having reduction. Note, the process of these two, oxidation or reduction, must happen together. Means that electron must go somewhere. You cannot like suddenly disappear somewhere in the space. Cannot. So must occur together. Means the number of electron must be balanced. Okay. It means if something have oxidation, another partners will have reduction. It's the same process. In the same process, you have two. If you have reduction, you should have oxidation. Only which member kena oxidize or reduce. And in test 2 and final exam, you need to use the word lose electron to explain oxidation. You need to use gain or electron or get electron to explain reduction. Means if you explain oxidation happen, you need to talk a little bit about electron. What happened to the electron? Is it electron added or loose? Yeah. Okay. Now another one. We keep giving new names to the one. Substance that oxidize. For example, group 1 to 3, they are oxidized. And the name we give to them, we call it reducing agent. They are opposite of the name. If you see an agent, means they are that opposite process. For example, you know that reducing agent, they are having oxidation. So the group 5 to 7, they are having reduction. So they are oxidizing agent. Understand? If you add a name agent, it's just opposite of the another side. Okay. If you have oxidation, they are reduction agent. If they are reduction agent, they are oxidizing agent or oxidizing agent. So this one, you need to be careful during test. We will play some wording games with you, ask you to identify reducing agent in the process. Don't confuse. A reducing agent means opposite of reducing meaning. Or reducing agent means the one that having oxidation. Okay, be careful on this wording game. So it's good to write some your own notes lah. Which one is oxidation, reduction? Okay. Then you can add some notes at the back. If it's agent, then this is O agent. This is R agent. It's a short note in your final exam or test too. Yeah. Reducing and oxidizing agent. So basically is the same concept lah. Only don't confuse it during exam. Okay. Read carefully. The question either asks you to identify oxidation or reducing agent. Just need to be careful a bit. Okay. So start from chapter 7 when you have an equation, especially gas, and then you need to tell me which one is reducing, which one is oxidizing agent. Okay. H, you know the H is more easier to give electron, right? Because they are in group 1 top here. This is H, this is He. H and helium. H, they are group 1, so they are more easier to give electron. So more easier to give electron, they are oxidation. So oxidation, they are reducing agent. So in the test, you need to copy the equation, then go under the equation, you need to tell me which one is agent, which one is reducing agent, which one is oxidizing agent. You only need to identify which one give electron based on periodic table. And let's say you have even you have group 1 and group, let's say you have group 1 and group 2 fighting for electron. Which one is more easier to give electron? If you have group 1 and group 2 fighting for reduction and oxidation process. Group 1, group 2, which one is more easier to let go electron? Group 1, it's more easier to kick out 1 person rather than 2 person. Okay, so the rest you read. The rest you read, I just don't want to confuse you, but as long as you know how to identify which one is oxidation, they are reducing agent. Then the rest is they must happen in the same time. Means if we have reducing agent, you must have oxidizing agent happen at the same time. Okay, so the rest you read. It's just repeating what we covered just now. Okay. Summarize, or you can memorize this diagram. I think one of the questions asks you to draw something like this. Okay. Okay. To summarize, oxidation is basically lose oxygen. So if you draw A, red color, reduce electron means the red arrow, it will become oxidation. It become reducing agent. Okay, reducing agent means A give it to B. A will be oxidized. Understand? Okay, the top diagram is what happened before. Below diagram is after, before and after. Okay, A give electron, it become reducing agent, or you can write oxidation process. A will be oxidized. If A give to B, B receive electron. Receive electron is oxidation. So sorry, receive electron is reduction. It is oxidizing agent. So yeah. Yeah, can. So just be careful on the definition of oxidation, reduction, or oxidizing agent, or reducing agent. Oxidation is a process. Oxidation is a process which tells the condition of the electron. If you use the word agent, they are referring to the substance. If you use the word agent, you see agent means you need to tell me what element, the substance, which substance is oxidized or which substance is reduced. Don't mix within these 4 definitions. Okay. Identify, we go through maybe one example and then the rest you can read from the slides. If you understand, you don't understand, you can ask me. Right? We go for number 1. And maybe you can memorize this diagram or the one that we write on the whiteboard there. Right? It's the same thing. Right? So first, to identify substance being oxidized and being reduced, this basically is back to the definition of movement of electron, or the one that is having oxygen or give away oxygen. There are 2 definitions. One you look at oxygen, one you look at electron. Okay. Magnesium, first equation, add electron and losing electron to oxygen. So magnesium you plus. So magnesium is oxidized, oxygen is reduced. What's magnesium plus oxygen? Magnesium plus oxygen is oxidation. Oxidation means magnesium was oxidized. And it must happen in the same process. When you have oxidation, they must have a reduction. Another member become reduction, right? So O2 will reduce or having reduction. Okay. Yeah. First example is oxygen. Second example is more on the electron. Huh? Okay. So B ferrum. Ferrum, they are electronegative non-metal. Reacting with electronegative non-metal. Cl, you know. Cl, I think, is group 6 or 7. Right? Need to refer back lah. But Cl usually is Cl negative lah. It's usually is group 7 lah. Right? So you know, if you see Cl is group 7, ferrum will be normally is group 3 or group 2. So from here you know lah. Ferrum, if it's in group 2, they are giving out electron, right? Give out electron means give up means oxidation. So ferrum will be oxidized. Then another member will be reduced. And as long as you capture one definition for oxidation, then that's it. You can just remember. Then other things was opposite already. Just capture one. Which one is oxidized? Which one having oxidation? Another one is another opposite. Okay. So if you catch ferrum, oxidized, Cl will be reduced or reduction. Yeah. Yeah. You can use shorthand just to write O oxidized, or you can just OZ something. Reduce is RED something. But in the test, you have to write the full. Okay, zinc plus Fe. Zinc lose electron because here before and after, zinc become Z positive. Z2 positive means it let go electron. Right, before and after, Z is not neutral, but Z after the process it become 2 plus. 2 plus means it let go 2 electron. Let go, if you look at our short-handed note here, let go is oxidation. So zinc is having oxidation or oxidized. Then another member sure is reduced. It must happen in the same time. Reduction and oxidation must happen in the same time. So if you see the word oxidize, if the question asks you to identify which one is oxidized, you must use back the same word. It asks you to be oxidized, you must identify which one is oxidized. Don't use oxidation. You can explain oxidation, but he asks you which one is oxidized. And if the question asks you to identify reduction agent or oxidizing agent, then you work accordingly. Okay. All right. This one is your homework. This one is your homework. It's the same thing. But what is important still this diagram and also the one that we write on the whiteboard here. You will understand this one, then you are fine and the periodic table. Okay. The rest you read. I just let you home and read this one. It's the same. Okay, this one, maybe a quick one. An oxidizing agent, A, B, or C. Oxidizing agent is always oxidized, is always reduced, can either be oxidized or reduced depending on the reaction. Oxidizing agent is what? Referring to our notes. Oxidizing agent is having reduction. They either give away oxygen or plus electron, right? So they are always reduced. Oxidizing agent means, if you see the word agent, means opposite meaning already. Okay. Okay. We go a little bit more, then we call it a day. We go into electron bookkeeping. What is electron bookkeeping? It's like a financial debit credit. Okay. We want to count the electron. We want to assign oxidation state based on the movement of electron and identify which one is having oxidation and reduction. There are some scientific way of doing it. Okay. There's one question on this oxidation state. Okay, so this one is just a repeating. If you have oxygen or highly electronegative element, what does this mean? Word highly electronegative element means they are more tendency become negative ion. Highly electronegative element, right? We are already substance oxidized, okay, by inspection. So this one, you've seen this one before. Okay. Okay. So we can readily identify substance being oxidized by inspection. Means, for example, corrosion of rust, the ion become chocolate color or brown color. Okay. Let's say you have carbon and sulfur. What is oxidized here and what is reduced is a bit difficult because they are group 4. So you don't know which one is which one. But the reaction is there. Okay. So these are the rules. These are the rules for bookkeeping. Okay, for bookkeeping, maybe we'll look back these rules when I give you the example. At this time, you just accept this slide first. Then we will come back to this bookkeeping. So first, you look at where does the electron go? I mean, atoms that attract the electron. You means that the first sentence here means you look at the periodic table. Either they are group 1, 2, 3, or they are group 5 to 7. Then we calculate the number called oxidation state and or the number. We will give an oxidation number in the calculation later. Either +1, +2, +3, or -1, -2, -3. Okay, so consider HCl acid. HCl, if you put in the liquid, you will see H plus and Cl negative. So chlorine, Cl are more electronegative. We know that Cl is group number 7. So the more tendency to become negative, right? We assign 2 shared electron in the bond chlorine. So then H, you know that Cl is okay, right here. Cl is group 7. They are more tendency to accept electron, right? So what, and then the process must happen at the same time. So if chlorine accept electron, what happened to the hydrogen? It must give one. Right? Chlorine group 7, in more tendency to receive one member. Where does this extra member come from? It must come from the hydrogen. Right? So hydrogen, it must accept. Hydrogen must lose 1 electron to chlorine, right? So hydrogen lose 1 electron. We assign oxidation state plus 1. Means we give card lah, red card, orange card, or green card. So if H give 1 electron, give away 1 electron, we will give them 1 plus 1 number to the H. Okay, plus 1 means it's just a number, oxidation state of plus 1. And chlorine it receive. It receive means we give -1. This is oxidation state number. Okay. Okay. Some of you might have careless mistakes. I put a 2 red color here. You know that if you mean ionic charges, you write 1 plus. The plus is behind the numbers. Right? Ionic charge, like for example, H plus. Right? So 1 is actually 1 plus here lah. Or Cl negative is 1 negative there. Right? But if it's oxidation state, the plus negative sign is in front of the number. This is the difference between ionic charge and oxidation state. So don't confuse. And your answer in the test also, don't flip the positive negative sign. If you mean oxidation state, the positive sign or negative sign is in front. If it's you mean ionic charges, the plus is negative is behind. Okay. This one I think is I give you in the handouts, right? In the tutorial question there, there's a table here. Right? This one, I forget whether I put this one in the appendix for test 2 or final exam. Ask me, when you have test 2 or final exam, ask me whether I give you this one or not. Remember to ask me, because I also forgot whether I got put this one in the question or not. Because the question was set like 2 months ago. Right? Okay, so this one normally I will give you. Mean this one is a Bible. What do? You just need to follow step 1 until step 5. Okay. Ignore the example. Ignore the example for now. Once you master 1 to 5, then you can look at the example. At the moment, ignore the example first. Okay, let's go one by one. What mean by 1, 2, 3, 4, 5? We go through by example. Okay. Okay. There are some rules there, red color. You must follow step 1 to step 2, step 3. You cannot skip. You cannot work reverse. You must work step 1, done step 1, then go to step 2. You cannot reverse. Once you have done step 2, you cannot look back anymore. You cannot like, hey, I -1 already. Then suddenly you +1. Cannot. You cannot like work reverse. Then, if any 2 rules conflict, follow the rules that had higher in the list. What does it mean? Like for example, this one. Or this one. So, you see which one meet the criteria first. Like for example, step 3, there are 2 conditions. You need to see which one come first. You follow hierarchy lah. Yeah. So you always follow the higher one, the higher in the list. Okay. Okay. This one is just example. We just ignore. Okay. So oxidation state. This one refer to their families lah. Actually refer to the family. Fluorine will be -1. So oxidation state will follow lah. -1. Hydrogen, this one standard. This one standard means we assume you know like gravity equal to 9.81 for chemistry 2. You might not see this one in your exam or final exam. This one we assume you already know. Okay? Mean in the question, if you see fluorine, straight away you don't need to calculate already. You see fluorine, straight away assign -1 for the oxidation state for fluorine. You see hydrogen, straight away assign +1. You see oxygen, straight away -2. You see group 17 means group 7. Group 17 -1. Group 16 -2. Group 15 -3. This one standard already. Means you no need to, you can memorize, but if you do more exercise, this one we assume you know already. Yeah. Okay. This one. So assign oxidation state. Yeah. So let's say number 1, Br2, bromine. Bromine is a free element, so oxidation state of both Br atom is 0. This one. Rules number 1. Oxidation state of an atom of the free element is 0. Means it's not ion. For example, if you see O2, no charges, means you follow rules number 1. Oxidation 0. Means oxidation number is 0. Can Br2 0. Rule number 1. Okay. So how you write? You write like this. Br2, you break into Br. Below Br, you write 0, 0. Yeah. I think we go through this until F, then we call it a day. Then we continue on Tuesday. Yeah. Okay. K plus. K plus is ion. So here, ion is +1. Rule number 2. So this one, oxidation state of a monoatomic. Monoatomic means one element. Monoatomic, it can be A plus, A minus, or something. Means it's only one element. Monoatomic ion. Ion. If it's not ion, you back to rule number 1, 0. Rule number 2, if you see ion, then you look at the charges. Is equal to its charges. So K1 plus mean 1 charges. So oxidation number is +1. If you see, let's say, if you see K2 plus, oxidation number is 2. If you see K3 plus, oxidation number equal to its charge, oxidation number is 3. Yeah, this is, so how you write oxidation state of K plus? You write like this, K plus, below there you write +1. This is bookkeeping, This is for electron bookkeeping. Okay. Number 3, LIF. LIF, we skip number 3. Why? Number 3, you read, the sum of oxidation state of all atoms in a neutral molecule or formula unit is 0. And ion is equal to the charge of the ion. So this one, there's no ion there. There is no, although there's no charges, but there's no oxidation states of all atoms. We also don't know whether it's 0 or not. So here is an extra special case. In their compound, metal have positive oxidation species. Group 1 is +1, group 2 have +2. So group 1 Lithium, if you look at periodic table, this one you look at periodic table, Li and F. Look at Li. Li is group 1. So you write Li. So this one is the special table that you see. Okay. Li, oxidation, Li is +1. Oxidation for F is -1. -1. Rule number 5. Yeah. The number must be balanced. Means if they are coupled, if Li is +1, F is -1. It must be, sum of that must be 0 because no charges. And okay, the sum is 0 because it's neutral. Okay, so this is a neutral compound, so the sum of oxidation state is 0 because no charges. You, from rule number 4, you back to rule number 3. A neutral molecule or formula unit is 0. Okay, so meaning the oxidation state of LiF is 0. But if you break the Li and F, there is a number there. Understand? Yeah. A bit more. CO2. CO2, you need to read number 5. Blah, blah, blah. Compound, we assign non-metal oxidation state according to hierarchy table. Show in the margin. So in the margin, you got you need to check, got fluorine or not, got hydrogen or not, got oxygen or not. Okay, this is stable, right? Neutral, right? In this here, you have oxygen, right? Oxygen is what? -2. So you look at you check whether got member got around here or not. Like for example, just now, LiF got fluorine. Straight away assign -1. But it must balance because no charges must 0. So F is -1, Li must be +1. Same with oxygen, right? So C must be 0, means the sum of this one is 0, no charges. So you follow rule number 3, neutral must be 0. So you write like this, C oxidation state plus 2 because got 2 molecule, 2 atom, bracket oxygen state. This is the first bookkeeping step that a bit complicated a bit. So you write C bracket C OX state plus 2 oxygen state equals 0. Why 0? Because no charges, CO2 no charges. Then you balance the equation. So C oxygen state is +4 and not +2 because got 2 oxygen there, 2 oxygen atom. Okay. So this is how you write lah. This is how you write, Why O2 is -2? Because it's already follow the table already. The table fixed already. Oxygen O2 is -2. But only need to be careful on the carbon, Yeah. Okay. I go very fast a bit. SO4 2 negative. Got sulfur or not? Got oxygen or not? Yes, SOFO2 2 negative. You got oxygen, 4 oxygen. You know that oxygen is -2. So this oxygen state is -2. So you read a bit lah. What is -2? What is rule number 5? Okay. So if that were the case, the sum of oxidation state would not equal to the change, equal to the charge of the ion. Okay. So because of oxygen higher on the higher list, you take priority. Because oxygen is above the S one. S is around here. Group 16. Group 16 is above the oxygen is above group 16. So we give priority to oxygen. Okay. So oxygen have higher priority, you take priority. So what does it mean? It means S oxygen state plus 4 oxygen state equal to -2. Again, you take oxygen, right? 4 4O2, OO state. So the S will be +6. Yeah. The rest you read PowerPoint slide. We'll revisit this one again. Okay, we stop at here. I view the final answer for Na2O. Next class, we will look at this example. Okay, we dismiss class here. Okay.